This is your assignment for today, page 386. Questions 40 to 46. You're only going to do the even ones. You're not going to use a calculator. 48 to 54, you can use your calculator, and 79 through 85, they contain variables, so you won't be able to use your calculator. The reason why I put this in a box is because these are just numeric values, but I don't want you to use your calculator for these examples because the instructions are a little bit different than the instructions for 48 to 54. So let's take a look at some of the examples you're going to have to do for 40 to 46. So again, this is an example where you have numeric values. Yesterday I said if you have numbers, no variables, just put it in your calculator. But these instructions are a little bit different. They want us to just rewrite it and keep it in radical form. If you put this in your calculator, you'll get a decimal. We just want to simplify this without putting in our calculator. And we're going to do it by using our rules for going from radical form to exponential form. In unit 6-2, 6.2, the rule for multiplying. In order to multiply, you have to have the same index. You remember that rule? So you can't just say radical 25. They don't have the same index. So that won't work here. Does everyone see what I'm talking about? What you can do, since you don't have the same index, you can take it from radical form and rewrite it in exponential form. Does anyone think they could rewrite this first factor in exponential form? How can we rewrite this, radical 5, in exponential form? Victor? 1 over 2, 5 to the 1/2 power. Radical form to exponential form. And how about the second factor? Victor, go ahead. 5 to the 1 over 5. So now we're going to just multiply factors that have the same base. And this is another exponent rule you need to know. If you have the same base and you're multiplying, what do you do with the exponents? You add the exponents. When you're multiplying and the base is the same, you add the exponents. So this is equal to 5 to the 1/2 plus 1/5. When the bases are the same, you add the exponents. So can you please tell me what 1 over 2 plus 1 over 5 is? Not 6 over 10. 7 over 10. 7 over 10. Common denominator, or you could throw that in your calculator. 7 over. Yes. 5/10 plus 2/10. You get your 7 over 10. So now we have 5 to the 7 over 10th power. The original expression was in radical form, so we must put our answer in radical form. So what is 5 to the 7 over 10 power written in radical form, Diavion?
The 10 radicals in 5, 7.
Yes, the 10th root of 5 raised to the 7th power. So the square root of 5 times the 5th root of 5 is equal to the 10th root of 5 to the 7th power. Any questions on number 41? Yes.
Sorry, how do you get the 7?
Sure, not a problem. So we got the 7 over 10?
Just the 7. I got it. Like the 10 is just the 2 times 5, right?
Actually, it's when we add fractions, we have to have a common denominator. So if we do 1/2 plus 1 over 5, we can't add these two fractions unless the denominators are the same. So we have to get a common denominator. So we'll do multiply this by 5 over 5, and this becomes 5 over 10. We have to multiply this one by 2 over 2, and this becomes 2 over 10. Now that they have the same denominator, we just add the numerators. We get 7 over 10. But this part right here, if you want, you could just throw that in your calculator and get 7/10. Any other questions from 41? All right, so let's look at number 43. Number 41 was multiplication. 43 is division. Again, the same rules apply. In order to divide radicals, you need the same index. So we can't just divide these. The indices are not the same, but we can rewrite it in exponential form and work it out that way. The numerator rewritten in exponential form is what? Haley.
4 to the 1 6.
4 to the 1/6 power. And what's the denominator?
Oh, sorry. And then the denominator is 4 to the 1/3.
4 to the 1/3 power. Thank you. If the rule for multiplying, if when you multiply the same base, you add the exponents, what's the rule for when you divide? If when you multiply, you add the exponents, what do you do with the exponents? You subtract the exponents when you divide. So since we're dividing and the bases are the same, we subtract the exponents. So this is equal to 4 to the 1/6 minus 1/3. So when you multiply and the bases are the same, you add the exponents. When you divide and the bases are the same, you subtract the exponents. So 1/6 minus 1/3. 1/6 minus 1/3.
But you said we could just put 1 6 minus 1/3.
Yeah,
Oh, so negative 6.
thank you. Negative 1/6. Our expression is in radical form, so our answer needs to be in radical form. In order to turn this into radical form, the exponent has to be positive first. We cannot switch forms with negative exponents. So how can we make the exponent positive?
Put the 1 over.
Exactly. So this is the same as 1 over 4 to the positive 1/6. And now that the exponent is positive, we could rewrite it in radical form. And radical form is what? Diavion.
Into 6 and the radical, then 4.
Thank you. 1 over the 6th root of 4. So these two examples that we just covered on the board, that's what I want you to do for examples 40 to 46. 48 to 54, you could do that straight in your calculator. Let's take a look at what I want you to do for 79 to 85. Now we're going to simplify each expression. So again, the rules we talked about earlier, if you have the same base and you're multiplying, you add the exponents. If you're dividing, you subtract the exponents. So here we have x to the 1/2 being divided by x to the 3/4. Since we're dividing, we're going to subtract the exponents. So this is equal to x to the 1/2 minus 3/4 times y to the negative 1/3 minus 1/2. Does anyone have any questions about how we went from this expression to this expression over here? Diavion? Sure. The rules for dividing bases that have exponents that have the same base. So x is the base here, x is the base here, so we're just going to subtract the exponents. So the exponent is 1/2 minus 3/4. And we did the same exact thing with the y. Madison, do you have the simplified?
For x, it's
Negative 1/4? All right. So we have x to the negative 1/4 power And how about y? Did you get that one yet?
No, not yet.
Did anyone get the y?
Negative 5, 6.
Negative 5 over 6. All right. Now this question just says to simplify. It doesn't say rewrite it in radical form. We didn't start in radical form, so I don't want you to think that you have to go back to radical form. The only time you have to go back to radical form is if the original expression is in radical form, your answer has to be in radical form. This is an exponential form, so we can leave it in exponential form once we're done, unless the instructions specifically say rewrite in a certain form. Does that make sense? So we can leave it in exponential form. The only thing is our exponents have to be positive before we're done. So what can we do to make the exponents positive?
Do, 1 over x, right?
Sure. So this is 1 over x,
To the 1/4.
positive 1/4. How about the y?
And then you do 1 over y to the 5, 6.
To the positive 5, 6. And this is just equal to 1 over x to the 1/4 y to the 5, 6. Everyone good? All right. Last one. So the rule, in case you don't remember, it's this rule over here. If you're raising a fraction to an exponent, the exponent goes to the numerator and the denominator, both factors. If you have multiple factors, the exponent goes to every single factor. If the exponent is outside the parentheses, it goes to every single factor, top and bottom. So take this rule and see if we can apply it to this example here. That 1/3 is outside of the parentheses. You must distribute it to every single factor, top and bottom. So this is 8 to the 1/3 power, x to the 6 times 1/3, which becomes the second power. There's an imaginary 1 here, imaginary 1 there. This 1/3 goes to every exponent, so it's 1 times 1/3. 6 times 1/3, which is 2. 1 times 1/3, so that's 27 to the 1/3 power. And 9 times 1/3, which is y to the 3rd. 8 to the 1/3 power. What is 8 to the 1/3 power? You have me on? 2. So the 8 to the 1/3 is simply 2. X squared, you can't simplify x squared anymore. What's 27 to the 1/3 power? 3. And you cannot simplify y to the 3rd any further. So 8x to the 6th over 27y to the 9th raised to the 1/3 power, simplified as 2x squared over 3y to the 3rd. That's the last example. Does anyone have any questions?